Hello everyone, today we're going to learn about regressions and quadratics. First thing I want to show you is that on this problem here, a football player throws a football off the top of a building. That sounds like fun, doesn't it? Well, anytime you throw something, we call that a projectile. And projectiles are things that are flying through the air that are free falling. Those are always modeled by quadratic equations, by parabolas. So anytime you throw something off a building or throw something anywhere, it's always going to make the shape of a parabola. For this problem, they give us the x values, which are the seconds, and then the y values, which are the height in meters. And so we're going to type the first one into L1 in the calculator and the second list into L2. And then we're going to use that to create an equation and then answer these questions down below. So let's get started. First of all, I want you to go to Stat and then Edit, and you're going to type this into L1 and L2 into your calculator. You can go ahead and pause the video if you need to do that. Next, now that you have those typed in, we're going to find our quadratic regression. You're going to go back to Stat, and you're going to go one right to Calculate up at the top, and you're going to go down to the fifth entry, which is quadratic equation. You probably remember before we did linear regression, which is a first degree polynomial. Now we're doing quadratics, which are second degree polynomials, and these fit curved shapes better and always fit projectiles. Once you press that, you're going to hit enter and just press enter, enter, enter all the way down to the bottom. Your screen should look something like this. And then you will get this screen right here, which shows your equation. You notice it gives you what A, B, and C are. If you have an R value right there, that R value just tells you how good a fit it is, where 1 is, the closer to 1 it is, the better. So you see if it's exactly 1, this graph, this quadratic formula, or this quadratic equation, goes through every single point. So it's a perfect fit. Now I'm going to type that into my y equals. So I press y equals and go ahead and type that in. You notice that last one's a 90. You just have to scroll over to type that in. And when you graph it, it won't look very good because it has a different domain and range than your standard -10 to 10. So what we're going to do is we're going to press window right here, and we're going to change the window to fit our data. Well, let's look at the data real fast. You notice the x values go from 1 to 6, so I'm going to make the x minimum 0 and the x maximum 7 right here. And the scale is just how far the tick marks are. So 0, 7, and 1 will make the left to right fit really well. And then on the y value, the height, we go from about 33 all the way up to around 110. So I'm going to make the minimum 0 for the y, just so we can see where the ground is, and make the maximum a little bit above our highest value there of 110. So just go ahead and put 120 in, and we'll put the y scale to 10. That way you know every mark represents 10 more meters high in the air. Once you've got your window fixed, now we can press graph, and we should get something like this, which looks like not only a parabola, but also the height of a ball as it's being thrown through the air. Now, let's answer some of these questions. I'm going to put the screen up here on the bottom so you can see both the questions and the graph. First of all, what's the initial height of the building? Well, we could use the y-intercept, and that's where x is equal to 0. So that's 90, because if we type in or plug in 0 here, f of 0, we would get 0, 0, and 0 plus 0 plus 90 is just going to be 90 there. Now, the other way to solve that is notice that where x is 0, that's the y-axis, or the y-intercept, and that's going to be right there on the graph. The nice thing is you can press trace and then type in the number you want. So if you press trace and then type in 0, you'll get 90. Now, right here, for the next question, what is the height of the football after 3 seconds? We're going to use exactly that. You go ahead and press trace and then type in a 3. And that's the same as if we plugged 3 into the function f of 3. So if you plug it in, you could just say negative 4.9 times 3 squared plus 20 times 3 plus 90 and do all that by hand. Or you could just come right here and see, oh, that's where the tick mark is 3. That's 3 on the graph when the seconds are 3. What is the height there? And if you type in, press trace, and like I said, type in 3, like this, then you'll get 105.9 as the y value. So that means at 3 seconds, we have 105.9 meters is where the height of the ball. The last question is, what is the maximum height? That's going to be the vertex. And yeah, you can kind of ignore that hint because, yeah, you want to find the vertex, but when you find the vertex, you get x and y, so you don't need to substitute to find the height. Right here on the graphing calculator, I'm going to find that by using the maximum, second calculate, then maximum. And when you go left, right, and then center, you get this value here, 2.04, comma, 110.4. Well, what does that mean? We got to think about this. X is time, and y is height. So that means that at 2.04 seconds, at about that time, we are about 110 meters in the air. Notice it says round to the nearest meter. So 110 meters in the air is the answer to D, and it took 2.04 seconds to get there. The last question we have is, after how many seconds does the football hit the ground? Well, we could set this equal to 0, and this is now an equation where we could use the quadratic formula to solve it. The other thing we could do is we could also graph it and find the zeros over the x-intercepts. Now I'm going to show you right here, this is at the end where I've done left bound and right bound, and now I'm looking to make a guess. Another tip, a pro tip while using the calculator, if you want to find the left bound and right bound, if you know an integer, you can just type that in when you're tracing. So you hit second, calculate, and then you want to find the 0, and I just typed in, I think it was 5 and then 7. So 5, enter, 7, enter, and then I'm going to make a guess right here, somewhere around where it intersects, and that's a lot faster than having to press and hold down the right button on the calculator. When you do that, you get this right here, and hopefully immediately something concerns you, but it shouldn't be too concerning. Notice it says 0, which is great, but then it shows y is not equal to 0. This is the calculator being as accurate as it can, but calculators are limited. And so always remember that the calculator does not tell you the answer. The calculator is a tool to help you get the answer. So let's think about this number here. 1 e negative 11. That right there is the y-intercept, or the x-intercept. That's where we want to find it. Does this point close enough? Is this point actually on it? Well, negative 1 e negative 11 means negative 1 times 10 to the negative 11th. And you guys should have already done scientific notation, but if you haven't, that means negative 0.000000001. And so I have to ask you, is that what value is the calculator really mean when it says times 10 to the negative 11th? It really means 0. And so this 0 here is an accurate enough 0. Now it's an approximate 0 because we had to, we obviously have to round that. And if we want to find the exact 0, we need to use the quadratic formula up here. So I'll go and show you what that would look like. When you plug A, B, and C into the quadratic formula, you get something like this. Negative 20 plus or minus the square root of 2,164 all over negative 9.8. And that is the exact answer. But be on the lookout. This says round to the hundredths. So this value down here is actually just fine. And our final answer is 6.79 seconds. And that is when the ball hits the ground. Thank you for watching. I hope you learned something.